and welcome to section 1.7, Functions as Graphs. I'm going to record this video and post it just in case class doesn't go the way I plan it to tomorrow, and this way you have it. But my expectation is that we're going to actually do these notes in class together, and you'll be able to use this as a backup in case you missed anything in class or you were absent. So, let's go ahead and recap. Today we're going to talk about section 1.7, which is to take that same idea of functions, except now we're going to look at them not as mappings or as tables, so much as graphs. Remember that we're doing a quick recap here. Functions represented as a dependent relationship between two values. The output depends on the input. Or we saw in our story problems that the range is a function of the domain. Ah, look, the next one just says that. The input is the domain of, or the x, and the output is the range or the y. Functions can be represented as tables, maps, verbal rules, equations, and graphs. You guys were asking what I was talking about. I saw a couple of you put that in your 1-6 WISC. And now we're here to talk about it. It was kind of a preview. I'm glad that a few of you caught that. Remember, the output, y, is dependent on the input. I just put purple polka dots all over this. Fun. Alright, example 1. Graph the function y equals 2x minus 2 with the domain 1, 2, 3, 4. Step 1. Make an ordered pair table. Someone in their 1-6 WISC, they were asking me about these domain values and whether they're always the same, and or if they're selected, or how do we come up with these domain values. And we have some common ones that we use, and we're going to talk more about that as we get more in depth into this domain and tables. I'll give you exactly what I want you to use as the domain. Now, I think that these horizontal tables are a little bit hard to look at. So when you start to see my tables, you're going to start to see them more often in a vertical format, like you saw before, where your x values get listed first. Right, you've seen these before. A t-table, I hope your teachers have called them in the past, a t-chart, where we put our domain values in the x column. We leave ourselves some space to show our work, so that it stays organized and we know what goes with what. And off to the side we get our range values or our y values. And when we do our work piece, we're going to go ahead and in this problem we're going to find the y value by setting it equal to twice the x value and then subtract 2. So to find y we need to do twice the x value, and in this row that's 1, then subtract 2. 2 times 1 is 2, and 2 minus 2 is 0. I'm pretty confident that you know how to finish this table, so go ahead and pause it and finish the table. When you blip back, it'll all be filled in. Alright, so hopefully you went through and you filled in all those inputs into the work zone and got all of the outputs so that we can record them here in our table. 0, 2, 4, and 6. And I think in your textbook that instead of using the word ordered pair, I think that they, instead of saying ordered pair table, I think they use the word organized. I think that's where this note is taken from. You use that word, organized table. Or an input-output table. At any rate, the key word is table. Make a table. That's got to be your first step when we have a graph and we were given a particular domain. Now in step 2, that's where that word ordered pair, that's where that word belongs. So we want to take this word, ordered pair, that I used here in step 1, and it actually belongs here in step 2. So we're going to plot the point for each ordered pair. Remember that ordered pairs are given x, y. That means that we plot the x value first and the y value second. So go to the x-axis first and the y-axis second. And it looks like this. I'm going to list my ordered pairs just so that we get used to seeing them listed out as ordered pairs, because that's definitely a skill we need to possess. So the first ordered pair, input of 1, output of 0. Input of 1, output of 0. So height of 0. That's our first one. Our second point is the point 2, 2. An input of 2 and an output of 2. Our third point is the point 3, 4. Point 3, 4. And the last point is the point 4, 6. Input of 4, output of 6. This problem, we haven't been asked to graph a line. We've only been asked to graph 4 pieces of the domain. Nothing in between. So we cannot, not connect these dots. Soon, but not yet. They gave us a limited domain. These are the only 4 points. The range is only 0, 2, 4, and 6. Nothing in between, just those 4 points. Alright, here is example 2. Graph the function y equals 1.5x with domain 0, 2, 3, and 5. Remember, you're going to make an input-output table. Input-output table. Then we're going to plot a point for each ordered pair. And I think that this one has a step 3, which is to state the range, but I'm not positive because I can't see the whole screen at the moment. Yep, nope, not even. We just got to do those 2 things. So this is a practice problem. Give it a try. Give it a try. So I have a little bit of